In this video, we're going to look at taking our completed class diagram and extracting our database structure from it and creating our ERD. So ERD stands for Entity Relationship Diagram. So very similar to a class diagram, it forms the entities, which in, I guess, our class diagram are what we call our objects, and the relationships, which we've defined as associations in this class diagram. But also with our ERD, it lists the attributes as our table fields. So it is very similar. I guess the difference with the ERD is it is our database structure. So as part of that, we do have to define our data types, which we don't necessarily have to in our class diagram. You certainly can. But the class diagram is meant to be more so for our Python code or our coded prototype. It is our structure for our code because it also contains methods. So the ERD is for if we're giving someone the database, we don't give them the class diagram. We just say focus on building the database with this entity relationship diagram. So to create this in star UML is pretty simple. It is a different model, so we're going to add a diagram. And towards the bottom, you'll see an ER diagram, which is our entity relationship diagram. And so you can see we've got our entity, which is similar to our class from our class diagram. And then we do have the different types of relationships. So one-to-one, one-to-many, many-to-many, very similar to when we discussed multiplicity in the previous video. In entity relationship diagrams, though, we do refer to it as cardinality. So I will start using that terminology. So just know they're the same thing. They're just in different formats in terms of the diagram. So we can go ahead and add our entities. So we had our publisher. We have our book. Keep thinking when I click it, it's going to automatically add. So I'm just going a bit haywire here, but that's fine. Customer. So I'll just try and line these up. You can always line them up at the end as well, but we'll try and get a bit of order happening. So with our relationships, and again, this is one that I always have a 50-50 shot of getting right the first time. So we know they're all one-to-many relationships. All right, so we want to get them so that I guess they sort of stem from order book and go outwards. So let's see if we can master that. I think because it's one-to-many though, you've got to go from one to many. Yep, and there we go. So you can see the symbolization is a little bit different. We don't use numbers and asterisks. We use the little sort of dashes and then the sort of squashed up M or crow's foot. So that's the way I remember it, is the one looks like a number one. The many looks like a squashed up M. So there is a second symbol there as well, referring to there's another sort of dash or a circle, and this refers to whether in the relationship whether it's optional or mandatory. So O for optional, M for mandatory. So what we're saying in this example is every book must have one publisher, but every publisher can have many books, but doesn't necessarily have to. So this would be useful in the example of, say, a lookup table, where you might have a list of values in one table that aren't necessarily assigned to the other table or the other object if we go back to our class diagram. But because we do obviously only want to store the publishers that we have books with, it doesn't make sense to have publishers details if we don't have books with them. We can change the cardinality, and you'll see it is referred to as cardinality in the attributes over on the right-hand side. We can change it to one to many, and you'll see it just puts that dash in there for us. All right, so we'll go ahead and we'll fill out the rest of those relationships. So one to many, and then we'll go back the other way, one to many that way, one to many. So I guess with the book and order book, so each order and book has to have one book attached, but each book doesn't necessarily have to be in order book. So if we've got books to sell and we haven't sold any, they're not going to be in any order. So this symbolization is fine for this particular relationship. I guess order book, we do need to have an order, otherwise why are we bothering? So we will change that to one to many. And so each customer, again, if the customer is registered in the system, I don't know why they wouldn't have made an order. So this one we will set up as a one to many. Okay, so we've now got our cardinality set up with our one to many relationships and our mandatory or optional aspects of that relationship. So once we've got that, we can go ahead and we can add column. That's right. I forgot that's what it was called. So to add our attributes, or what we call fields, in our table, we just simply add a column. And I'm pretty sure with this one, it was just the publisher's name and the email to contact them. So once we've got the column names in there, we can add the other details in the properties section. So the one we do want to include is the type. And you'll see there's a whole range of types. Because we're using SQLite, we're just going to use a simple text for most of these when it's a text. If you're doing MySQL or something like that, there is a few more options like varchar or char or what's the other one I'm trying to think of? No, I can't see it there. I guess they're the main ones. Yeah, so varchar, char, or text basically is for any of your strings. But because we're using SQLite, they just use text. So nice and easy, type text. The other thing we can identify in here are things like our primary keys and our foreign keys. So if I click primary key for publisher's name, you'll see PK comes up on the left here, which represents that this is the primary key of the publisher table. So now we just go through, we do the same thing for each of our others. I just need to quickly remind myself what's on each one. So we've got the ISBN, the publisher, the title of the book, the author, and the price. So ISBN is actually a number, so you could use integer, but technically because it's a number we're not going to calculate on, we would normally use a string type data type. So I guess if you're using MySQL or something like that, you would use char because it's a set length. But again, because we're only using SQLite, I'm just going to use text. So the publisher is type text, title is text, author is text, and the price. So because the price is generally, a decimal number, we'll use float. So the two main types of numbers, integer is for your whole numbers, and float is for the decimal point. You can see there is, again, some more specific examples if you're getting into MySQL or those more advanced SQLs, but we're not too concerned with that. All right, so order book, it just has the ISBN and the order ID. Actually, I forgot to add the keys. So primary key for ISBN, publisher is a foreign key. So I just realized previously when we looked at order book, we didn't discuss the primary keys. I'll just quickly put in the data types, text. Order ID will be an integer type because we'll just get it to automatically generate a number for us. Just stretch this out a little bit. So with this one, we can have what's called a composite key. So a composite key is when we combine two bits of information to create a singular primary key. So I guess this is unique in that they both represent the primary key together, but they're also technically foreign keys of the other table too. So, you know, foreign key referring to the book and order table respectively. So I'm just going to push these out a bit more. So we'll go ahead and add in our order. So order ID. I remember customer email was there. What else did we have? So I just realized from our previous one we had book. I'm actually going to remove that because the book is stored in the order book. So that's one thing I forgot to fix up. Might have to make a little note under the video on that one because we don't edit, we don't redo. Customer email, so just quantity and date after that. Alright, so order ID is an integer type. And so it is important as well when you've got primary foreign key connections that the data types do match up. The system will throw a fit otherwise. Customer email is just text. Quantity will be an integer. And date, so again, there is a set date, time, those sorts of data fields, but again, we're only using SQLite, so text is fine for the date. And I forgot customer email is in fact the foreign key. So email, what else did we have? Try and remember name, the street address or PO box, suburb, postcode. Can never spell postcode right when I'm typing. Password was one. Was there anything else? Oh, phone number. Again, you can adjust the order if you want, but I'm not that concerned at this point. So text type, it's also the primary key. Name is text. Address is text. Suburb is text. So again, postcode and phone number are examples of numbers where we won't necessarily have to calculate anything. So we can just save them as text types. Again, in more advanced SQL solutions, you can format things like the postcode has to be 4 numeric symbols, so 0 to 9 basically. Same with phone number. You know, you can set that it's got to be a digit and it's got to be 10 digits in length, but it's not an integer because I guess if you save it as integer, particularly with a phone number, the 0 at the front will just get taken off. So text is important for those numbers in quotes where you're not actually calculating. So things like order, because we will get it to basically add one number to the previous order to create the new order ID. That's an example of where we would use an integer. The quantity, because we want to calculate the price, that's an integer. But the ones where we're not necessarily calculating them can be just saved as text. But then when we got to that stage, we've now got ourselves our entity relationship diagram for our online bookstore example.